Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at 3.11 still. We're looking at a little extension of it. This is part 2. So if you need to just know how to solve trig functions, go ahead and watch that first part. This video we'll still be looking at solving, but it might take another step or two. We're going to look at it now and how to do it when there is a horizontal dilation of some sort. So notice this first one, sine of 2 theta equals 1/2. Well, realize what we are trying to solve for. We're trying to find theta. We're trying to find this angle. Well, if we need an angle, we need to figure out what sine value produces this. So really what I'm asking myself right now is sine of what gives me 1/2? Right? What angle gives us a sine value of 1/2? Well, let's realize sine is a y value of a coordinate. So we know the y value on the unit circle is 1/2. Let's go to our unit circle. Let's find the spots that occurs. Notice that would occur at pi 6. Realize y is positive in quadrant 2 as well. So we end up getting two different solutions for this. One answer we end up getting is pi 6. But realize the unit circle, it repeats every 2 pi. So we would have to add 2 pi with that, and pair that with k, as k is some integer. So that just says every 2 pi. We have a second answer of 5 pi 6. Again, make sure you repeat it every 2 pi k to make sure it encompasses all solutions. But when we're solving this, you need to be careful, because we didn't just have sine of theta equals 1/2, we have 2 theta. So we just found what 2 theta must be equal to. Well, from here we can get theta by itself. You could divide the 2 over or multiply by 1/2. It would do the same thing. Pi 6 times 1/2 would end up giving us pi 12ths. Make sure you multiply both parts. This 2 pi k also needs to get multiplied by 1/2, giving us pi k, as 2 over 2 would cancel. That is one of our solutions. One of our general solutions, I should say. Same idea on the second one. Make sure you divide the 2 over. You get 5 pi 12ths plus pi k, and there is your second general solution. Let's go ahead. Let's look at some other examples of what this stuff might look like. Tangent of 3x equals 1. Again, notice what we need. In this case, our variable is on the inside of the parentheses. Let me rewrite that now. Okay, so we need to find some angle that gives us a tangent value of 1. If you don't have your tangent values memorized, remember, tangent is just the slope. So anything in the first and the third quadrant would be positive because the lines are going up. Anything in the second and fourth quadrant for tangent would be negative because it's going down, right? You can look at the slope of the lines. Well, when we look at the unit circle, there's really 3 lines we look at inside the first quadrant: pi 6, pi 4ths, and pi 3rds. What we know is that pi 4ths has a tangent value of 1, right? Root 2 over root 2, root 2 over 2 over root 2 over root 2 ends up canceling out, giving us 1. Tangent at these other spots, if you go through the same process, give you root 3 over 3 and root 3. I have shown that in one of these videos. I believe it was the last one, 3.11. So if you need to figure out how we got those values, please watch that video. So, okay, here are our other values. So what angle gives us a tangent value of 1? We know that would be at pi 4ths. So what we end up finding is, okay, we get pi 4ths for our angle. We know we can add 2 pi k with that and come up with our other angles. But tangent doesn't have a period of 2 pi. Tangent only has a period of pi. So I really don't even need a second solution. Because if I looked at the third quadrant for the tangent value there, it would just be the one that adds with pi fourths. Pi fourths plus pi would give us 5 pi fourths, which is the angle in the third quadrant. Tangent, you only need one solution, in other words. From there, get the x by itself, divide that 3 over, and you end up getting the general solution of x equals pi twelfths plus pi thirds k. And now we're done with that second problem. 2 more examples I want us to look at, just discussing some other things. Remember, arc sine is the same thing as sine inverse. Okay, whenever you hear arc, that does mean inverse. In order to move functions to the other side, you need to do the opposite operation, right? Just like when you add something, you move it to the other side by subtracting. Well, when we have sine inverse, the opposite of it, the inverse of it is just sine. So to get rid of sine inverse, I'm going to take sine on the other side. Well, before I can solve for the variable, I've got this problem that's happening on this left side. Sine of 0. Well, be careful when you look at these problems. You need to understand what they're asking for. Right now, we have sine of 0. The value on the inside is an angle. We know the angle is 0. And we want to figure out, okay, what is the y value at the angle of 0? So you could go to your unit circle if you need. What is the y value at an angle of 0? And that looks like 0. So, okay, when we end up evaluating here, be careful, make sure you're paying attention to whether you're finding an angle or if you're finding a coordinate value. In that case, we were finding a coordinate value. So on number 3 now, what we need to do is figure out, okay, where is tangent equal to 0? Notice the x on the inside, that means we need an angle. So where is it equal to 0? That would be at an angle of 0. So, okay, what we end up finding is 0 still equals 2x, but this 0 occurs every pi k. Again, it's tangent, so you only need one solution, and its period is pi. Divide the 2 over, and you end up finding x is equal to pi halves times k. The 0 goes away. That is our general solution. Number 4 as well, we can start to solve for our variable, move whatever's on the furthest outside. So in this case, I divide the root 2 over to the other side. But we're dealing with secant, and secant is kind of annoying because I don't know my values on the unit circle for secant, right? I don't know them for cosecant either. I know them for sine, I know them for cosine, I know them for tangent. Remember though, secant is a reciprocal function. It is the reciprocal for cosine. Well, remember, reciprocal just means flip the fraction. So if I want to take the reciprocal of secant and change this into a cosine function, that works. Notice the inside of the function doesn't change. The reciprocal is the secant to cosine part. But if I take the reciprocal on the left side, I must also take the reciprocal on the left side. The right side now. And that gives me negative root 2 over 2. So now really what I'm asking myself is, okay, what is the angle that gives us a cosine value of negative root 2 over root 2? Cosine is negative in 2 spots. Cosine is negative in the second and third quadrants. We know root 2 occurs at the pi fourth marks, so that would be 3 pi fourths, as well as 5 pi fourths. Don't forget to generalize it with the 2 pi k, as it does repeat every period. Now you can get x by itself. To get rid of the 6/7 part, you can multiply by the reciprocal. right? You could multiply by 7 to get rid of the 7. You could divide by 6. In other words, I'm multiplying 7 6 into this whole part. When we do that, you could see if anything cross simplifies. For example, I see 6 and 3 here. Those would cross simplify. 3 over 6 is 2. So 7 there stays. And I would just have 2 times 4 on the bottom then, which is 8. Multiply the 7 6 with the 2 as well. 2 over 6 would give us 1/3. So we would end up giving 7 pi. This is a 3 on bottom. 3 times 4 gives us 12. And there is part of our generalized solution. We look at the second one as well. Again, it's done by doing the same process, multiplying 7 6 into both of these. One thing you might do is just show the 7 6 multiplying with both parts individually. I know some people can see what's happening a little bit better there. 6 and 5 don't simplify, 7 and 4 don't simplify, so I do just need to multiply across, giving us that. Here, though, the 2 and the 6 still simplify. 2 over 6 is 1/3, so this gives us 7 over, that last one, let's fix that. 7 over 3, or 7 pi thirds times k. Okay, my fault on that last one. 2 over 6 is 1/3. There was no denominator of 4 on that. I was looking at the 4 from the last one. That was my mistake. But now we do have our generalized solutions for this problem, and we are done. That is our 3.11 notes, just analyzing and solving these trig functions. Make sure you've got your unit circled down. It makes these problems a whole lot easier. Thanks for watching.